Second part of learning target 3A. This is all about modeling inequalities. So we're going to be dealing with some more word problem formats. So in our last video, we talked about how do I solve an inequality and graph the solution set. This video is going to focus on, well, what happens if I have that in a word problem format? So let's read our first example. Number 15 says the hard drive on your computer has a capacity of 250 gigabytes. You have used 105 gigabytes so far. You want to save home videos to your hard drive. What are the possible sizes of your home video collection you can save? Set up and solve an inequality, making sure to define your variables. So the first thing we want to think about is, well, what am I given and what am I trying to find? So we're given a couple pieces of information. We know that the capacity of our hard drive is 250 gigabytes. That's the largest. So far, we have used 105. And what we are asked to find is you want to save home videos to this. So we're asked for what are the possible sizes of the home video collection that we can save. That's what we're really looking for here. So when we set up and solve our inequality, we really want to first start with what are our variables that we're going to use in them, and we need to define what they are. So I'm going to start by defining our variable. So x is going to be what I'm solving for, and x is going to equal what we're looking for. What are the possible sizes of our home video collection? So x will equal the size of our home video collection. That was 2 L's. Sorry, that got a little messy there. That's a little bit better. Okay, now that we have our variable defined, we can go ahead and think about our inequality. Now you might be solving this in your head already, which is great, but you have to first set up a problem on the paper and then we're going to solve it from there. So let's think about on the side kind of what's happening here. So we have the current space used. So we have let's call it what's already used. Just shorthand this. So what we have already used plus the size of the video that we're trying to figure out if it will fit. That has to be at most the hard drive capacity that we have. Because it wouldn't be possible to put more on our computer than what we have space for, which is why we have it as an at most statement. So now let's think about, well, how can I take that information and transcribe it into what we were given? So what we were already using is the 105. So the 105 gigabytes is already used. Too bad we already took it up. Plus the size of the video that we're trying to figure out is x. That has to be at most, so that has to be smaller than or equal to the total hard drive capacity, which is 250. So I know at most makes it think like, oh, it's bigger than it, but no, that actually means it's smaller than it because our hard drive capacity is the biggest that it could possibly be. So 250 has to be greater than or equal to what I've already used plus what I want to start storing. So we've defined our variables, we've now set up an inequality, and now we're going to go ahead and solve it. So to solve this inequality, we would subtract 105 to the other side and get x is less than or equal to 145 gigabytes, technically, if we're thinking about the units there. And we have now solved our inequality. But all of this thought process is necessary in order to demonstrate that we understand what's going on in our problem. Let's look at our second example. So number 16 says that we earn $300 per month from your part-time job. You are in an online gaming club that costs $30 per month, and you save at least $150 each month. That's what we want to save at least. We want to write and solve an inequality to find the possible amounts of money we have left to spend after we pay for our gaming club and put aside what we're trying to save. Then it says make sure to define your variables. So let's go ahead and kind of highlight what are we given and then what are we looking for. So we're given a couple things. We earn $300 per month at our part-time job. Our gaming club costs $30 per month, and we want to save at least $150 per month. What we're trying to find is the possible amount of money we have left to spend after we put those two away. And of course, we want to make sure to define our variables first. So I'm going to let x equal the amount of money that we have left to spend. That's what we're looking for in this problem. So it would make sense that that would be our variable. Let's think about on the side again. Well, what's everything? What are all the moving pieces? So the first thing we have is the gaming club. So that's a cost. We also have how much we want to save plus how much we want to spend. That has to be at most, again, our paycheck. Let me slide this over and get a little bit more space. There we go. So that has to be at most what our paycheck is going to be. Oops. Come on. There we go. So again, we're dealing with this at most concept, which means everything I'm spending. So the gaming club, the saving money, what I'm trying to figure out what I have left to spend has to be at most equal to our paycheck. So when we start putting numbers in, we have 30 plus we're trying to save 150 plus, well, I'm not sure how much I can spend. That's our variable, so that's our x, is at most, so less than or equal to our total paycheck of 300. Again, you might have been doing some of this stuff in your head, and that's okay, but we also have to make sure that we're explaining on a test or on a quiz how we would go about solving it. And part of this question is to write and solve an inequality, which means I have to first write it down without solving it. So here's our inequality statement. And I also have to define the variable that I used in that inequality. From here, we can go ahead and solve this. So I'm going to combine like terms on the left and get 180 plus x is less than or equal to 300. Subtract 180 over, and that would mean that x is less than or equal to 120. And if we're thinking about units, this would be $120. So that tells us that I have at most $120 left to spend after I pay for my gaming club and put away money into my savings account. Okay, actually we can probably leave it there. Let's look at our last example. So in example 17, it says, in your garden, you want to fence in a rectangular vegetable garden. The width has to be 15, and we have at most 48 feet of fencing. What are the possible lengths? Set up and solve an inequality. Make sure to define your variables. So let's go ahead and highlight what we're given. So we're given a couple things. The width has to be 15. So something about this garden is forcing the width to be exactly 15. And then I have at most 48 feet of fencing. What we're looking for are what are the possible lengths. So let's start by defining our variable. So I'm going to go ahead and use L this time. So we're going to let L equal, it's a little messy. So L is going to be equal to our possible lengths that we have. The other thing that I didn't highlight but is going to be important is we need to recognize what type of garden we're creating. What shape is this creating? Well, this is going to create a rectangle. And as I'm talking about a rectangle, I have a length and then we also have a width, which they gave us. They told us our width had to be 15. So in a rectangle, we have a length and a width, but we know in this case, our width is going to be equal to 15. So I can label that as 15. We're trying to fence it in, which means we're dealing with the perimeter of this. So I'm going to use P for perimeter. And if we're trying to find the perimeter of a rectangle, it would be the length plus the width plus another length plus another width, or 2L plus 2W if I combine like terms. So our perimeter here for this one in particular is going to be equal to 2 times the length plus 2 times 15, since we know that our width has to be equal to 15. Now what we're given in this scenario is that the perimeter is at most 48 feet. Because if my perimeter is bigger than 48, then I have not enough fencing, so the perimeter here, RP, is at most 48, since this is the total amount of fencing that we have. and I can't create an area with more fencing than I have. So what that tells me then is that my perimeter is less than or equal to 48, but we know that our perimeter is equal to 2L plus 2 times 15, less than or equal to 48. We have now set up our inequality, and let's go ahead and solve it. So simplifying, 2 times 15 is 30. So I get 2L plus 30 is less than or equal to 48. Subtracting 30 over, we get 2L is less than or equal to 18 then. Dividing through by 2, and that would give me that my length is less than or equal to 9. And we were able to solve, and if we're thinking about units, we are in feet. So my length has to be less than or equal to 9 feet for this example. And those are 3 examples of modeling inequality.